So solving radical equations. To solve a radical equation, first thing is isolate one radical. Most of them will only have one radical, so you just isolate the radical. But if there's more than one, you start by isolating just one of them. Square both sides of the equation, and then solve the remaining equation. The fourth step is verify the answer, which actually is pretty important in this case, which you'll see later on. In order to isolate that radical, we first need to subtract 7 from both sides of the equation. So we get the square root of y minus 1 equals 6. And then the second step is square both sides. So square this and square this. When you square the square root of y minus 1, you have just y minus 1. And then 6 squared is 36. Then solve the remaining equation. This one's easy because once you square both sides, you're left with just a linear equation. So just isolate the y. Add 1, y equals 37. There's the answer, but we still need to verify that. So to verify it, how do we verify the answer?
Do the equation.
Put it into the original equation. So this verify looks like this. The square root of 37 minus 1 plus 7 equals 13. So that's root 36 plus 7 equals 13. 6 plus 7 equals 13, so 13 equals 13. That means that it works, it's right. Radical here is already isolated, right? It's m equals the square root of 2 minus m. The square root of 2 minus m is the only thing that's on that side of the equation, so it's already isolated. We can skip that and then just square both sides. You can't square both sides until you have just a radical on one side of the equation by itself. We already have it, so we'll square this and square this, and we get m squared equals 2 minus m. What type of equation is that? Quadratic, right. And we know how to solve a quadratic equation. I hope you remember, because we just spent like a month on it. Get everything on one side of the equation. So we'll change this to m squared plus m minus 2 equals 0. So add m to both sides, subtract 2 from both sides, and then factor if possible. If not, you have other options, right? But I think this one you could factor. Plus 2 minus 1. What does m equal? -2 and 1. I still need to verify. So I'll start with the -2, and we'll go -2 equals the square root of 2 minus -2. 2, that's 4. And I get -2 equals the square root of 4, which is 2. What does that tell you? It doesn't work, right? -2 doesn't equal 2. So this, well, one of two things is happening. Either we made a mistake, or we have an extraneous solution, and the other one might be a solution. Do you think we made a mistake?
No.
No? Nobody sees a mistake there? Okay, so we're going to assume for now that's an extraneous solution, and we'll reject that. Just going to write that down. Solution. That's an extraneous solution. Basically, what an extraneous solution is, it's an answer that works for a modified form of the original equation. If we were to take -2 and fill it into the second step, it would work. It just doesn't work in the original once we've changed it by squaring both sides. But it works in the second one. And when you square both sides of an equation, you do sometimes end up with extraneous roots, because it makes an equation that's equal in most cases. But not always. There are these extraneous solutions. So let's look at checking the second one. We'll go 1 equals the square root of 2 minus 1. 1 equals root 1. 1 equals 1. That one works. So this has one solution. M equals 1.